Okay, so yesterday we touched a little bit on maximum and minimum. So in order to get maximum and minimum, or look at that, we need to look at what on this equation? Is this going to be a smiling graph or a frowning graph?
Smiling.
It's going to be smiling. Is smiling maximum, or does it have a minimum point? Has a minimum point. Remember Mario yesterday? Mario is the maximum where he jumps up, right? Okay, so let's look at the next one. What's that one going to look like? It's going to be frowning, which would mean maximum. Has a maximum point. Okay, what about the next one?
Minimum.
Minimum. Good. So this one was max, and this one was minimum. Let's try these. Maximum. Good. This one?
At maximum.
Why? Tell me why.
Because it's negative 2.
Because it's a negative 2x squared. This is what judges whether or not it's going to be maximum or minimum. Let's ask this. Let me rewrite it. What's this graph look like? No.
Then you plot it one.
I plot it one, so it would be shifted up one. And then what would it be a skinnier graph than x squared, or would it be a wider graph than x squared? Remember that? We talked about how as
Yeah, but we
no, we did it for 2 days.
do.
Yes. For 2 days, we compared when you have a coefficient in front of x. If it gets larger, it either gets skinnier or it gets fatter. And if it becomes a fraction, it either gets skinnier or larger. Anybody remember?
Actually,
What does bigger mean? No. It's going to get skinnier. Here's 0. Here's 1. Isn't a half closer to 0 than 1 is? And a 4, even closer. And an 8, even closer. So as you have a fraction, it's actually getting closer and closer and closer to 0. That's why the fractions get closer to 0. And when it's something like 10x squared, what would 10x squared look like? It's a negative 10x squared. It doesn't shift up or down because there's no c. But it's going to be a frowning face. And is it going to be really skinny or really fat? Really skinny.
because it's not.
Because this number is not just, the negative makes it point down. It's higher than 0.
So if that was negative, it's right to
Ooh, it should be pointed down. You're absolutely right. You made a mistake. And by we, I mean me. It's up 1, it's skinnier, and it's in the negative direction. Good catch, Patrick. About this one? Maximum or minimum? Minimum is, where would I shift? Up 1. It's going to be a little bit wider, and it's going to be positive. Okay, just trying to visualize this stuff. Okay, let's move on. Again, we're visualizing, so no writing. Given the axis of symmetry, vertex, and direction, your job is to sketch the parabola. So help me sketch this parabola. Maximum, does that mean it's going to be smiling or frowning? Frowning, right? Mario's jumping up. That's maximum. if I have an axis of symmetry at x equals 5, that means I would have a dashed line over 5. Which direction? To the right or to the left? To the right. X is 5. So I would go over 5 and I would say I have a line. Uh-oh. I'm losing. So this is my axis of symmetry. Exactly. So the vertex is going to lie on that line. Specifically, we also know the x value is that first number, right? Because if I go over 5 and down 3, that's going to be my vertex. And since it's a maximum, I know it's going to look like that. Well, it didn't give me any more information than that, so I'm sketching. That's why this is a sketch. So do this one. X is at -1. So -1 would be going over to the left of the y-axis by 1. And then I would plot my vertex at -1, 2. So as I go over -1, I need to go up 2. Is this going to be smiling or is it going to be frowning?
Smiling.
Smiling. I'm going to sketch. Whoa. Sketch it like that. I think that looks a little bit better. What, Patrick? Yes. So we're going to learn today how to find that axis of symmetry. Okay. Go ahead and write this down. You don't have to write all of this. I just want you to put axis of symmetry and vertex. Actually, you know what we need to do? We need some graph paper. So let's pass out some graph paper. So this says, wouldn't it be nice to know exactly what values to choose for x to get the perfect symmetric U shape every time? What commercial does that remind me of? I don't know. I'm thinking it's something. Wouldn't you like to get the perfect something every time? What commercial am I thinking of? I know. That's fine. Thank you for reminding me. Okay. Never mind. It just sounds catchy is what I'm trying to say. Wouldn't you like to get that perfect symmetric U shape every time without having to wonder? Well, I've got the answer for you, the axis of symmetry. So we're going to use this formula to find the axis of symmetry to get that perfect symmetric U shape every time. But like I said, if you forget how to do this, you guys already know how to graph this stuff. This is just making your job a little bit easier. Does everybody have this down? Pencils down to begin with. I just want you to watch what I do. So I'm going to model how to do this for you. Okay, so I've got this graph. Y equals x squared plus 2. First of all, I already know what this looks like. If you think about it, it's going to look like it's going to be shifted up 2, and it's going to look like that. Right?
Yeah.
I know that because of behaviors of graphs. I already know that. But since we know it, now we can just graph it, and we'll know if we're right. Okay, so let's start with the fact that all of this stems from a quadratic equation. Y equals ax squared plus bx plus c. So based on this equation, what would a be in this equation? No. X squared is right there. What would a be? 1. What would b be? 0. There is no b. And what would c be? 2. Excellent. All right, so that being said, now let's talk about the axis of symmetry. In order to find x, and by the way, from this last slide, x is also going to be the first number in the vertex. So I'm doing two things, killing two birds with one stone. So I'm also going to put for vertex, I'm finding the x value right here. Finding this x. All right, so let's plug in our values. I don't like putting negatives in front like this because they get lost. So should I put the negative up here or down here? Doesn't really matter.
B.
Let's put it in front of the B. All right, so B is 0, so this should be 0. And A is 1, so I'll put 1 here. 0 over anything is just 0. So I'm going to put 0 here. I know my axis of symmetry is 0. I'm going to draw a line, actually right on the y-axis there, the same as the y-axis. And I'm also going to throw a 0 in here because this is going to be my first point. So yesterday, how many shells did you have to write? Oh, one more thing. Do you guys often forget if it's 0 over a number makes 0, or does that make end of 5? Does anybody forget that? I always forget that. I saw this in the teacher's room. It's really clever. 0 over a number is okay. A number over 0 is not okay. Be okay? No. Isn't that clever? Now you can always remember it. Okay. It doesn't matter. That's being resourceful. Okay, so yesterday we needed 4 shells, I told you. Today we're going to break it down to 3. I need to see that equation first. So y equals, I've got an x squared plus 2. So I'm going to write that out 3 times. Y equals something squared plus 2. Y equals something squared plus 2. Let's start throwing in values. What's the first value I'm going to throw in? I found that x is 0, so I'm going to find out what y is when x is 0. What's y? 2. Good. There's our first point. 0 up 2. That's my vertex. That's my line of symmetry. From here on out, all I have to do is graph the right side, because then I know symmetrically the left side. Correct? Mm-hmm. All right. So what's the next point you want to put in? 1 is the easiest. Let's plug in 1, and what do I get? 3. Oh, we forgot to put our vertex over here. What's my vertex? 0, what? 2. If I go over 1, I go up 3. Since I know this is my axis of symmetry, if I have to go over 1 this way to plot a point, can't I also go in the other direction and plot a point? Technically, but I want you to do 1 more, because we just want to see what the top of that looks like. So what's the next number you want me to throw in? 2 would be good. 2 squared is 4. 4 plus 2 is 6. So if I put in 2, I get 6. Over 2, up 1, 2, 3, 4, 5, 6. I know if I go in this direction over 2, I should hit 6. Therefore, I should also be able to get to 6 if I go in that direction too. And there's my parabola. Yep. We only need 3. It's only going to take 3 shells to give you the behavior of this graph. Does that match what we had up here? Yep. Okay, let's do one together now. You're only going to do 2 graphs. So on your graph paper, just split it in half and do a graph in the top portion of your graph paper and one in the bottom. Make sure you have a T-chart. Make sure you've got your equation, the steps, 1, 2, 3, and I need 3 shells. Write that out so we can just get this going. All right, let's take care of this one. So I'm going to start by saying what's A, B, and C. What's A class?
1.
And B?
6.
And C?
5.
Good. We need to plug in for the axis of symmetry. So I'm going to say x equals negative 6 over 2 times 1. What is negative 6 over 2? Negative 3. So I'm going to put negative 3 right here. I'm going to put negative 3 right here. And I'm going to put in my 3 shells. y equals x squared plus 6x plus 5. Because that's what we just found. That's x. We need 3 of them. Right? We're going to find those 3. I already know my axis of symmetry. What's my axis of symmetry? -3. We just found it. So that's going to help me out a lot. 1, 2, 3. Let's figure the rest of this out. If I plug in, so what's the first number I'm going to plug in? No. You would always put in 0, right? But now I already have my first number. What's my first number? -3. I already found it. That's going to be the beginning point of my vertex, right? So -3 squared is 9. 6 times -3 is -18 plus 5. Well, I know -18 and +9 make -9, and -9 plus 5 makes -4. So I know that goes here. Please don't crack up yet. So if I go over -3 on my axis of symmetry, I'm going to have to go down 1, 2, 3, 4. Everything will be symmetric after this. What's the next easiest point I could possibly put in? 0. 0. Isn't 0 always the easiest?
Those 5. 0, 5.
Exactly. I put 0 in, and I get 5. So I'm almost done. 0, I go up 1, 2, 3, 4, 5. If I know that point, I also know if this is 3 away to go this way, it must also be 3 away to go over here. I only need one more point. What do you want to use?
1. I need 1.
You wouldn't want to do 1 because that will take you all the way up here.
2.
Let's do -1. See what I mean? The graph's going to look like this. So let's do -1. -1 squared is 1. 6 times -1 is -6. Positive 5. Positive 5. What comes up from that?
1.
0.
Wow.
-1, 0 means I have 1 there, and I also have 1 here, and we're done. Good job, guys. I'll see you tomorrow.
I think you, Michael.
No, he's not. All right, guys, have a good day.